Hello, we're gonna do nature of fruits today. So this is usually the last question on the algebra question 1 on your paper. So nature of roots. The roots are the x values that you find when equating that quadratic expression to 0. You know, those x values that you got. And then we have the quadratic equation. So let me go back a little bit. Quadratic equation. So it is what x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. Sharp. But in this quadratic equation, the b squared minus 4ac, it is called the what? The discriminant. Then we are gonna put it like this: delta b squared minus 4ac. It is the discriminant. And then you have the types of roots. We have the real roots, we have the equal roots, we have the real and unequal, we have the rational roots, we have the irrational roots. These words are you remember them grade 10, eh? And then you have the what? The non-real or imaginary, or imaginary. So these ones are the ones usually the negative numbers, no? Sharp, ne? So now let's go. I want to go back to describe the natural numbers and whatever, you know them. So you are not gonna describe the nature of roots using the discriminant of delta. This thing, using this thing, it is equals to b squared minus 4ac, and you are gonna do it graphically, ne? So when the discriminant is greater than 0 or positive, there will be a two real and unequal roots. Is it fine now? So I'll go there and show you whatever I have, but for now I want you to know this thing. So in your graph you can have something like this. They always use a parabola. Then I'll have my thing like this. Then these are my x-intercepts. Is it fine? So you know your b squared minus 4ac, it is now what? Greater than 0. You have your two x-intercepts, and then you have two real and unequal roots. These are the two real, and then you have the unequal roots again. Is it fine now? So now let's go to number 2. I have my graph here, and then I have my thing. They don't, you see, it is not even touching this thing. So you are gonna know that your b squared minus 4ac, it is what? It is less than 0. There is no x-intercept. Therefore the roots are what? Non-real. Is it fine now? When the discriminant is less than 0 or negative, there will be no roots. The roots are non-real or imaginary because they are no x-intercepts. So number 3. So I only have what? One x-intercept. And at the same time, it is the what? The turning point. So when the discriminant is equals to 0, so manje, it is what? The equal root. So whereby my b squared minus 4ac, it is what? Equals to 0. The turning point lies on the x-axis. So you have the two equal roots. So my b squared minus 4ac is equals to 0. The x-intercept, it is now equals to the turning point. This is the point. I have the x-intercept at the same time as the what? The turning point. Is it fine now? So now let's go to number 4. When the discriminant is equals to a perfect square, a number whose square root is a whole number, you know that most. And then there will be a real and rational root. So b squared minus 4ac, it is now equals to a what? Perfect square. Ne? When the discriminant is equal to a perfect square, a number whose square root is a whole number will be real and rational. So now let's go to number 5. So now I have what? When the discriminant is not equals to a non-perfect square, then there will be a real and irrational root. So let me say b squared minus 4ac, it is not equals to a perfect square. You see now, these are the two differences now. So now let's check the summary. So this is my roots. This is my what? Discriminant. Sharp. Is it fine now? Let's continue. The first one, it is the what? The real roots. The real roots, whereby your discriminant, it is what? Greater or equals to 0. And then number 2, I have equal roots, where your b squared or your discriminant is equals to 0. Number 3, I have equal, unequal, let me say real and unequal roots. So the discriminant, it is what? Greater than 0. And then I have the rational, whereby the b squared minus 4ac, or the discriminant, it is what? Equals to a perfect square. And then the irrational, whereby what? Your discriminant, it is not equals to the perfect square. You see the difference? This one is kind of easy. And then the non-real or imaginary, then the discriminant, it is what? Less than 0. You see, guys, this is what it did. When the roots are real, the discriminant, it is greater or equals to 0. And then when the roots are equal, the discriminant, it is what? Equals to 0. When the roots are real and unequal, the discriminant, it is what? Greater than 0. When the roots are rational, the discriminant, it is what? Equals to a perfect square. You know a perfect square. And then when the root it is irrational, the discriminant, it is what? Not equals to a perfect square. When the roots are non-real or imaginary, the discriminant, it is what? Less than 0. Is it fine, guys? So now let's check an example. I nearly forgot. So before you go to examples, let's go to steps to approaching nature of roots. So number 1, write polynomial into a quadratic form. So they will give you a complicated equation, but when you will do what? You will write it into a quadratic form, which is what? Ax squared plus bx plus c. The reason why I said write the polynomial, it is because they will give you terms that are more than 4. And then they will complicate things now. Then number 2, choose the roots from the table and the corresponding discriminant. So you're going to choose the roots from the table, and then this one, and then to the corresponding discriminant. Number 3, identify ABC from the polynomial or quadratic equation. So identify ABC using this one. It will be in this form, so we're going to choose it from this form or the polynomial. Lastly, substitute into the discriminant and solve. Okay, is it fine now, guys? This is how you do it. So now let's check an example. So now you're gonna do an easy equation, then you'll do more as time goes on. So it says, for which values of k will the equation x squared plus x is equals to k have no real roots? Okay, no real roots. See? And then now let's move on. It means what your discriminant must be less than 0. Already I'm gathering some information. The first thing that you do, write down the polynomial into the quadratic in form. But already it is not complicated, so I can say x squared plus x minus k, it is equals to 0. I can take this k as a constant, and then I know my a is 1, my b is 1, and then my c is what? Minus k. And then it is what? No real, non-real. Remember I said what? Choose the roots from that table and then to the corresponding discriminant. Is it fine now? So it is gonna be what? So since now, wait, let's continue. So now since I know what my a is equals to 1, b is equals to 1, and then c is equals to minus k. This minus, it is basically telling me that I have what? No real roots. So my b squared minus 4ac, it is what? Less than 0. So now I'm gonna substitute. My b is what? 1 squared minus 4. My a is what? 1. And then my c is what? Minus k. And then I say my equals to less than 0. And then I have what? 1 minus, minus 4. And then I have what? Minus k less than 0. So it is the same as 1 minus and a minus, it is a plus 4k less than 0. And then I'm gonna do it like this. Take this 4k to the other side, or this one to the other side. But 4k, it is what? Less than negative 1. Then I do what? Divide both sides by 4. Therefore, my k, it is what? Less than minus 1 over 4. You see? That's how you solve these things. It's very easy, guys. The first thing that you must do, choose the polynomial, write the polynomial into a quadratic form, and then choose the roots from the table. You are gonna determine that, and then identify A, B, C, and then this is how you do it. Okay, thank you, guys.